Why is Switzerland burying its electric turbines? Hey, detailed engineering! Have you heard that Switzerland is burying its electric turbines under the mountains? Sounds strange, right? But behind this, there's a brilliant strategy to solve one of the biggest challenges of renewable energy, which is how to store energy for months and ensure light, heat, and technology during the harsh alpine winter. That's right, Switzerland, known for its lakes, precision watches, and fine chocolates, is leading a silent revolution, literally burying solutions underground. But what does this have to do with turbines, and how can this change the future of global energy? But first of all, why store energy seasonally? Imagine that in the summer, Switzerland produces excess solar and hydroelectric energy. But in the winter, consumption skyrockets because of heating, but generation drops, rivers freeze, and the days are short. That's where seasonal storage comes in, which is storing the surplus energy from summer to use in the winter. But how? In batteries? The answer is no, because they're good for hours or days, not for months. And what's the solution? Use the country's own geography. Switzerland wants to be carbon neutral by 2050, but it relies heavily on hydropower and energy imports in the winter. And the problem is that climate change is reducing the glaciers, and Europe is facing energy crisis. The solution is to store water high up in the mountains during the summer and release it in the winter to generate electricity. But conventional reservoirs are not enough. Switzerland is burying high-power hydroelectric turbines, key parts of a system called pumped storage hydro or pumped storage hydro in English. This method is like a water battery on an industrial scale and works in two stages. First, the third step is charging the batteries. In the summer, when the sun shines brightly and Swiss hydroelectric plants produce more energy than the country consumes, the excess electricity is not wasted. Instead, it powers giant electric motors that pump water from lakes or rivers in low-lying areas to artificial reservoirs at the top of the mountains. Some over 2%. It's like filling a bathtub on the top floor of a building, storing gravitational potential energy. Then it's time for the strategic release. In winter, when snow covers the Alps and the demand for energy skyrockets, the stored water is released. It goes down through vertical tunnels called penstocks, gaining speed until it hits the turbine blades, which can spin up to 500 revolutions per minute. The movement of the turbines drives generators, converting the kinetic energy of the water into electricity. But why underground turbines? Here's the trick. To maximize efficiency and minimize environmental impact, Switzerland installed these turbines in caverns carved into the heart of the mountains. The NANDEDRANCE project, for example, is an underground power plant the size of Notre Dame Cathedral, with 6 reversible turbines capable of pumping water up or generating power as it flows down. Each turbine weighs 450 tons and generates up to 150 megawatts enough energy to power 400,000 homes during peak consumption. While lithium batteries lose charge, the Swiss plant maintains 80% efficiency even after decades. In addition, a single reservoir like Nandedren stores 20 million cubic meters of water, which is equivalent to 8,000 Olympic-sized swimming pools, ensuring energy for months, not just hours. These turbines also act as crisis dampers. In case of water shortages and blackouts, they take less than 10 minutes to reach full operation, stabilizing the grid. It's engineering that combines ancestral sustainability with the power of water and cutting-edge technology using control systems automated by artificial intelligence. In other words, what seemed like the burial of turbines is actually a reinvention of the water wheel, only on an epic scale. And you thought Switzerland only made watches? But it's not simple. Digging through mountains requires billion-dollar investments and facing geological risks. The Neanderthals took 14 years and cost $2 billion. Besides that, the efficiency is about 80%, meaning 20% of the energy is lost in the process. Even so, Switzerland bets on this because the Alps offer perfect elevation differences for the pumping. And this strategy reduces dependence on Russian gas and nuclear energy. And for each megawatt stored, it prevents the burning of tons of coal. Now, the big question is, can this be replicated in other countries? Yes, but with adaptations. Places without mountains can use compressed air in caves called compressed air energy storage or green hydrogen. Switzerland is already planning to expand projects like Greensill 3, which will use artificial intelligence to predict demand and optimize storage. And the most amazing thing is that these water batteries can last 100 years, making them sustainable in the long run. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, leave your like and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're looking for personal and professional growth, scan the QR code here on the side or click the link in the video description to gain access to various opportunities to develop a range of skills that will make a difference in your career. Had you ever thought about the possibility of using water as a battery? Did you know about this Swiss project? Leave it here in the comments, I want to know. Right here on the side, there are two interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to contribute, leave your like, subscribe to the channel, activate the bell, and consider becoming a member of the channel. That's it, engineering lovers. A big hug, and I'll see you in the next video.